The next speaker in our session is Dr. Fan-Kui Zeng. He is a research scientist in potato processing research in the National Potato Industry Technology System in China. He has been a visiting scientist at the School of Food and Advanced Technology here at Massey University in Palmerston North between April 2019 and April 2020. And then he was conducting research in the area of potato processing with Dr. Jaspreet Singh and his team. Dr. Zeng's current areas of research include potato protein, starch, potato processing, waste resource utilization, sorry. And today's title of the talk is Industrial Recovery of Potato Protein, Fruit water and land treatment of deproteinized wastewater effluents. Yeah.
Good afternoon, everyone. Firstly, I would like to thank the conference committee for providing me an opportunity to share my research. I would like to share some of the latest aspects of industrial recovery of protein from potato fruit wort and land treatment of deproteinized wastewater effluents. We have translated potato chemistry and technology into Chinese. The Chinese version of this book will be published by China Light Industry Press. From April 2019, I worked with Jaspreet and Lovedeep as a visiting scientist at Massey University for 1 year and studied potato processing. I really enjoyed my study and life at Massey. I miss everyone alone in New Zealand and the ducks, the lonely black swans and eels in the Palmerston North campus neck of Massey University as well. Potato is a key industry related to China's food security and the implementation of targeted poverty alleviation. China's potato starch processing is mainly in the north. The processing time is winter. The processing time lasts for about 1 month. With large potato fruit wort discharge and high organic matter concentration affected by the low temperature in winter in the north, it is difficult for conventional anaerobic and aerobic biochemical treatment to meet the discharge standard. Potato fruit wort contains about 1.5% protein. The protein can be recovered by acid and heat coagulation. A starch plant that processes 500 tons per day of potato raw materials can recover 4 tons of protein powder per day. With the funding of the research pilot project of returning potato starch processing wastewater juice to the field in Guiyuan City, the research on the land treatment of deproteinized wastewater effluents was carried out. The results showed that the returning deproteinized wastewater to the field could effectively improve soil fertility, improve soil structure, significantly improve soil aggregate structure, and bulk density, reduce the use of chemical fertilizer by 15%, and there was no charge in bad chemical components such as heavy metals. Compared with the clear wort control, the appropriate application of wastewater juice can effectively improve the crop yield, and the silage corn yield can be increased by 51.3% to 67.59 metric tons per hectare. The main risk of returning deproteinized wort to the field is environmental protection. including surface water pollution, groundwater pollution, soil pollution, air pollution, and so on. Our findings suggest that the risks are manageable through our efforts. Potato protein recovery and land treatment of deproteinized wastewater have been written into the National Environmental Protection Standard issued in 2018. But in this standard, it is all simply described in a few sentences. We have drafted a very detailed technical specification and held several meetings with the relevant government authorities to discuss it. This draft standard is based on our experimental results. If this standard can be promulgated and implemented, we will create the history of potato processing in China. Acid and heat coagulation has been applied to recover protein from potato fluid. However, due to the high content of glycols in the recovered protein, its application has been limited to some extent. We are looking for technical cooperation. Deproteinized wastewater as fertilized water is very suitable for the arid area of North China, but the impact on the environment should be fully considered. At the end, I would like to thank Professor Zeng, Dr. Navdeep Kaur for their cooperation. I look forward for more and more cooperations from all over the world.
Thank you, Fan-Kui. We saw a lot of familiar faces in those pictures, so it was really nice to see. There was even a picture in front of the building that we're currently in, so thank you for that. And great to see that you're doing some really important work in the field to protect the environment and growing potatoes.